Today's learning targets, be able to graph a logarithm function. Remember, we're doing this without a calculator, a basic one. And biggie is rewrite from log to exponential form and exponential to log form and evaluate logs with and without a calculator. All right, so on worksheet 3, it says we learned about inverses, right? In 1.7. Well, the inverse of what we did yesterday is called a logarithm function, okay? We did exponential functions yesterday. So it says you can see the exponential form f of x equals b to the x will pass the horizontal line test. Therefore, there is a one-to-one inverse, and that inverse is called a logarithmic function. That's a big deal when we start talking about domain and range and graphing, is that these are just inverses of what we did yesterday. All right, it says it's time for the video, so I'm going to pause. Okay, so the video, oh, wait, now I got to turn that off. Okay, the video, yep, let's get the tablet working, was log base b of a number equals a power, which would be written the base to some power equals the number. Yes? So if you want to write those down, you certainly can, because that's not the letters that are on your sheet, right? But I think it does help remember that this one is the base, and the answer to a logarithm is always the power, or the exponent. So, everybody got what they want on that? This is what you have at the top of your sheet, okay? And I should just change these and letters, and it would be more helpful probably, but the things you have to know is you have to know very clearly how to switch back and forth between the two, okay? But you also have to know that you can't take the log of a negative number. It says here the base has to be greater than 0, and the number you're taking the log of x has to be greater than 0. Because there's a question on the quiz that says something like the log base 2 of negative 64. And that would mean 2 to what power is negative 64? And is there a way to make a power turn a positive number into a negative number, guys? No. So you have to know that and just write not possible or whatever on the quiz, okay? So it's no calculator, so make sure you get, okay. So practice. Who's got the first one? Destiny? How do we rewrite that? Beautiful. So number 2, Brandon? 17 squared equals 29. And this is a nice one because it's kind of self-checking, but I'm more likely to put one like this on the quiz that's not, so that you have to know where things go. Can you rewrite this as a log, Jacob? Log base A of B equals 20. Yes, guys? Okay. The base of the exponent part is still the base, A. The answer is the exponent. There we go. We good? When I teach it for the first time, like to an Algebra 2 class, I usually do cutesy little shapes because they have trouble figuring out what I'm talking about. So it's this to this equals this. Just memorize it somehow so that you know how to rearrange it. Okay, number 4, Jack, you got that one? Log? Base 7, yep. Of? Good job. Everybody okay on those? That should be totally review. All right, then some basic properties of logs. And these should kind of make sense. Some of them are a little bit trickier. log base b of 1 is 0 is saying b to the 0 is 1. Does that make sense, guys? Anything to the 0 power is 1. Okay, this one is saying b to the 1 equals b. Makes sense? Yes? So the log base 6 of 6 means 6 to what power is 6? So the answer would be 1. You can all rewrite that and think about that. This one, for me, this is really a property that we're going to learn tomorrow. But do some of you remember this from last year? Like if you had this, that this 3 can go out in front as a multiplication. Okay. So to me, that's how I think of this one. It says log base b of b to the x is just going to be x. It's because if I had put a 3 here, I could move that 3 out front. And so then I'd have 3 times 1 is 3. They're explaining it as it'll just, okay, I'll do it on the next slide. And the next one is b to the log base b of x is x. Let me see. These also work with natural logs. Here, this is the one that we're struggling with explaining just a little bit. Log base 10, which is understood. Everybody's good. LOG, when there's no base, is understood to be 10. You remember that from last year? And this one says of 10 to the x. Okay, how would I rewrite that as an exponent? Equals something. So what would that look like? The base is 10. The exponent is something equals this, which is, so now does it make sense why it simplifies down to just x when you see it written that way? Okay. And then this one, log, no. Sorry, I didn't write it right. 10 to the log of x, which is also base 10 of x. They want to talk about what to do with that. What kind of a problem is that currently written as? An exponent. So how do I rewrite it as a log? If I say this equals something. Log, and the base was 10, of something equals log the exponent, which was log base 10 of x. Now, does it make sense that it simplifies down to x when you do that? Okay, so that's how I always think about those, is if I just rewrite them, I'll be okay. All right, and it also works when we see ln, because ln just means it's base e. Everybody good? All right, I knew you'd remember this stuff. Okay. It does say down here, if you try to take a log of a negative number, you'll get an error message, but on the quiz, you don't get to use a calculator. All right, here we go. This is no calculator, so let's practice. Now, I would need to rewrite this probably. How would I rewrite this? It always is looking for the exponent, guys, when it's a log question. So 5 to what is 1/25? Anybody want to help me out there? What is this? 25 is 5 squared. But how can we get it up out of the basement? To the what? Negative power. Yes? So this is really 5 to the negative 2. Everybody okay with that? So if we, what's happening? What's our little answer here? The little box has to be, okay. So we're asking, what is this power of 5? And that is negative 2. All right, what about B over here? What power of 3 is that? 1/3. Be careful. 1/2. There you go. 3 to what power equals the square root of 3? And this is 3 to the 1/2. We revisited that idea yesterday. So the answer is 1/2. You certainly don't have to do all those steps. I'm just trying to show you, if you were stuck, how you could think about those steps. Questions? Anybody need more time on that slide? All right. What about this one? What's the base down here? E. So if we rewrite that, it is base E to something equals what? Okay. You know what my brain says here? Remember that property we're learning tomorrow? I would just move that out in front so that it says 7 times the natural log of e. And then this is saying e to what power is e, so this is all just a 1. Either way, everybody could get a 7. The quiz is not till after we've reviewed those properties anyway, so they will help. Anybody remember this one? You got a guess? 5? Yeah, that'd have been my guess too. It is currently an exponent, right? So e to the ln of 5, oops, I kind of wrote that way up high. So if you were rewriting it as a log, you would say this is equals something. You would say log base e of, what am I doing? Of something equals ln of 5. Well, this is really ln, right? Log base e is really ln. So then we just get 5. That was not a good explanation. Anybody need me to go back over that? Let me fix it for the notes slides. Log base e, which is really ln, of something equals ln of 5. So this is ln of something. So it was 5. All right, back over here, same thing. Is log with nothing down there the same as the base 10? So is this not the same idea? E and ln and the exponent undid each other. 10 and log base 10 are going to undo, and we're just going to get 13. Am I okay to move on or not? Okay. Number 1, explain to me how you think of that. Yeah, 7 to what power is 7, Destiny said. Everybody think of it like that? 7 to what power is 7, so the answer is 1. Okay? What did we just talk about this one? If I rewrote this, it would be log base 10 of something equals log of 5x. So what goes in there? Just 5x. And these are both exponent power of 3 and log base 3, so they're going to undo each other and get a 2, same as the last one. Everybody okay? I'm just going quick because we got to do graphing still. Number 4, Brandon S., can you do that one? Six to what power is 36? Are you on the right spot? This is what it means. There we go. Got to be able to rewrite those and do them quickly for the quiz, okay? This is a trickier one. Anybody think they got this one? Xavier? 3 to what power is 1 over 81? So 3 times 3 is 9, times 3 again is 27, times 3 again is 81. So we had 4. So this is 3 to the 4th, and then he said because it needs to come up out of the basement, the answer was -4. Do you remember a peach sheet that had cubes and cube roots, a little half sheet? You had a list of cubes and cube roots and 4th power. If you still have that, you can use it to practice, because I'm going to give you one of those the day of the quiz. So if you can't figure them out, you know, if the numbers get too big for you to do in your head because you don't get any kind of calculator, you will have that little list. Okay, number 6. Haley, got a guess? Yeah. The e and the ln will just undo each other, so we end up with x squared I do have some more practice on this. Do you want a little bit more real quick? I want to move on to graphing, but you have that sheet out. Anybody? This is saying 8 to what power is 512. Is it on that sheet? It is 3. Good. And this one, these would undo, right? Log base, if we think of this as moving out front, kind of previewing tomorrow's lesson, log base 4 of 4 is going to go away, so we just get 3.2. Anybody know this one? 2 to what power is 32? That's on your sheet. Yep, and what put it in the bottom? And, 36 to what power is 2 to what's the power of, that made it a square root? Oh, thanks. Yep, the old lady in the bifocals got me again. Can't see that at all. Okay, what power of 2 is 16? Look on your sheet if you need to. 2 times 2 is 4, times 2 is 8, times 2 is 16. So this is 2 to the 4 somethings equals 2 to the 1/2. Can you set the exponents equal? So 4 times something is 1/2. 1/8 is right. If we take a fourth of this side to get rid of that, we have 1/8. Yeah, I didn't put that on the quiz. Okay. All right, I am skipping. Oh, but I like these. What's this one? 10 to what power is 10,000? How many zeros? Ew, that's a calculator question. Can you do -0? Not possible. And that one? Yeah. All right. I'll stop. Maybe. Which one is a calculator question? Actually, I think we can do that one without a calculator. This is a calculator question, and this is a calculator question. This one should be what? Just 4. And this is saying e to what power equals 1 over e. So what's that? Just -3. Yeah, you got it. All right. Do we have this question? Yes. Mrs. De Silva has $3,000 to invest. She'd like to invest in an account that compounds continuously. They give us this fancy-dancy formula. How long will it take her balance to be 6,000? So where does the future balance of 6,000 go in? The A, yeah, be careful. For her. Yeah, but, it is, wait a minute, I can't read the question. Is there, how long will it take her balance to be? But this is what we want it to be now. She's investing this. So her original, yeah, it's a little confusing the way it's worded. She wants her current balance to be 6,000. So we have, that goes here. And P, her original investment was 3,000. P is the original principal. That was this one that she was investing. You good? Okay, and then it's equals R times T. Do we know either of those numbers? Okay, so can we do all this on our calculator? You got to close a parenthesis, I'm thinking, though. Yes? Because it was the formula. Right here, ln of A minus ln of P, okay? We will eventually know how to do this with the PERT formula. This is a very messed up use of PERT that because we don't know how to do all this yet, they're trying to give you a fake application. ln is down here on the side. It was the 3,000 first. Thank you. That would make sense. Minus ln of 3,000. You do have to close the first parenthesis there. And then divided by 0.06. Anybody get 11.5 years? Okay. And we're just going to go with that for today and we'll be done. 11.55 years or 11.6 years. Any questions? Any applications today are basically just typing in. This one says the Richter scale measures the magnitude of an earthquake. Here's a fancy formula. E is the energy released in kilowatt hours. The amount of energy released is 1 million kilowatt hours. So where does that go? It's the energy, right? It says E is the energy released, and this says the energy released is 1 million kilowatt hours. So 0.67 log 0.37 times, we got to put the whole million in, right? Because it doesn't say that this measures in millions. It just says it kilowatt hours. And then at the end, there's supposed to be a 1.46 that I left off because I don't have room. I could try to rearrange it, but there we go. Try it. 0.67, then how did it go? Log base 10. And what was in there? Times 1 million. Plus 1.47, thank you. So we got that this was a 5.2 earthquake, anybody? Oh, it was supposed to be 1.46? Okay. So 5.19, which is roughly a 5.2 earthquake. But thank you for fixing it. That's the Richter scale reading. Okay. I hope we're out of those. Okay, we get to graph. Here we go. The inverse of an exponential function is called a logarithmic function with base. The inverse is log base b of x. So, guys, yesterday we graphed y equals 2 to the x. Today we're going to graph log base 2 of x. These are inverses of each other because, do you remember, how do you find an inverse? If you switch the x and y, now what? How do we solve for y? We don't know how to solve for y here, right? But if you rewrite this as an exponent problem, what will it say? As a log problem? Mouth is not working. Log base 2 of x equals y. Remember, the answer to the log problem is the exponent. The answer is the exponent. So now did we solve for y? Did we get y by itself by rewriting it? Okay, so these are inverses of each other. So if you don't know how to graph this and you know how to graph this, what are you going to do? Take all the ordered pairs and switch the x and y, yes? Or you graph this and it reflects across what line? So there's the line, and there's what all the ordered pairs are going to look like. So an exponent, a logarithmic growth problem will look like this. What is different about that from exponential growth? Exponential growth grows very fast, yes? Remember yesterday when we did this? Depending what the rate is, it can grow very fast. But this is growing much slower, yes? But it is still a growth problem as long as the base is greater than 1. The things you need to know for the quiz are domain range, that it only crosses the x, okay? And the asymptote is the y-axis. It is approaching on the right. It will approach infinity. On the left, well, first of all, it doesn't go towards the left. It only goes to 0. So I'm not going to ask you end behavior on that. This is a decay, which would be if, for example, you had log base 1/2 of x, then the graph would look more like this. Okay? All right, there can be transformations. It says, remember that horizontal translations are dependent on the constant inside the parentheses. Vertical are dependent on the outside the parentheses. So what would this do? Just discuss the transformations. This is a quick review, guys. Inside, so it shifts what? Left. This one has two things going on. Now, I hate that they do this because in my brain, this should be here. Okay? So there's a parenthesis there. So the negative first reflects over the x, and then this one would shift it down 5. It's down here. This one, what's the 3 do first? Vertical stretch, and then this one is left 2. Okay, so here's what it looks like on your quiz, and it will be, on your notes, and it will be this easy on the quiz. It says log base 6 of x. You have to find 3 ordered pairs. This is not a nice one for doing on the quiz, but there's a couple things you could do. You could rewrite it as an exponent and then take all the ordered pairs and switch them. Or what are some numbers that you can take log base 6 of easily? Log base 6 of what? 6? Yeah, 36 would work, but 36 isn't going to fit on my graph paper. This is what? So I put in a 6, I got out a 1. Some other easy ones aren't so easy for us to think about, but 1/6 would be what? So we put in a 1/6 and got out a -1. So we could put that on as an ordered pair. That's what this is, 1/6. All right. And the other one is 0. It's actually log base 6 of 1. So this is saying 6 to what power is 1? 6 to what power is 1? 6 to what power is 1? 0. There we go. So this is, we put in a 1 and got out a 0. That's this one. All right, I want to do one that isn't done on there, and we'll feel a little better about ourselves if we can think of some things that work for 3. Do you want me to rewrite it as an exponent, or you just want to think of it as a log? Anybody have a preference? Log? Okay. What could I put in there that would give me out some nice answers? I can't do 0. I can do 1, 3, 1/3. 9 would work. I think it'll still fit on the graph paper, maybe. Maybe not, but okay. Log base 3 of 1 means 3 to what power is 1? 0. Okay. Log base 3 of 3 is 1. Log base 3 of 1/3. 3 to what power is 1/3? Good job. And log base 3 of 9 would be 3 to what power is 9? 2. So if I plot those, I have at 1, it's at 0. At 3, it's up at 1. Notice the weird graph paper. At 1/3, it's down at -1, which is here. Okay. And out at 9, which we don't have. Let's see, 4, 6, 8, 9 would be out here. It would be up at 2. All right. Can I just run through the other way you could do this real quick? If you had rewritten that as, well, you could have written it 3 to the y equals x, and then you could have put in numbers. 3 to the 1 is, whoops. If you're going to rewrite it that way, you're putting in y values. Everybody paying attention so you see what your choices are here? If you rewrote it, you could have said, I'm going to put in a y is 1, that'll give me a 3. I'm going to put in a 0, that'll give me a 1. I'm going to put in a -1 for y, that'll give me 1/3. You see what I'm talking about? If you don't like logarithms. All right. Now, tell me about domain and range, because this is on the quiz. We have not talked about this yet. So what is the domain for this one? Is it? Can you take the log of anything? Did the graph have x values that went all the way left to right? Can you take the log of a negative number? Remember, we started that out. And look at the graph. Where does it start? The furthest left it gets is close to 0. The range, on the other hand, is... Hey, do we need to bring up yesterday's slides? Remember what happened yesterday? Yesterday's graph of this 3 to the x looked like this, remember? The domain was all real numbers and the range was greater than 0. What are we doing now? Don't the domain and range flip with the x's and the y's? Ah, there we go. Okay. Intercept. Yesterday the intercept was 0, 1, so today it is 1, 0, and it's an x-intercept, not a y. All right, asymptotes. What is the asymptote for this? Yes, x equals 0 or the y-axis. It is a vertical asymptote. Very good. End behavior, I'm going to skip because it's not on the quiz. Is this one increasing or decreasing? It is increasing, and the values of x for which it is increasing are the domain values 0 to infinity. All right. I do not want to spend a lot of time on this one, but what two things have happened to our graph here? Flipped over the x, which would look like this, right? 2 to the right. So the asymptote is here. Used to cross at 1. It's moved 2 to the right to here. But where it was going up 2 boxes and over 2, it's now going down. So it looks like this. And then we would do the graph analysis. All right. The homework is here on page 178, okay? I didn't do application, but I'm not sure there's much for applications on here. It's all just plugging in numbers, okay? This is a cutesy one about a computer virus, but you just plug in a 12 right there. Then you plug in a 30 and subtract the difference. How would we do if we wanted to know when does it reach 75? You'd put the 75 over here, and we don't know how to work backwards, so we would solve it by graphing. Yes, yes, put it in Y2. Okay? I think you got this. Thanks for your patience at the beginning of the hour and your helpfulness with my technology issues. Oh, no, I meant to.